I am Brahma, and today I would like to show you my project that is Morris Shell. So, Morris is a reactive and declarative shell language focusing on implementing a reactive approach of scripting to system orchestration and manipulation. In the current digital world, the performance is critical and outdated dependencies seriously affect productivity at a large scale. Morris aims to replace traditional scripting paradigms like that of Bash or PowerShell to a reactive engine that maintains predefined state and adjusts itself to changes in external variables. So normally what happens is that while handling large systems such as databases, servers, cloud, or AI, changes to code or design pattern is crucial for development. But oftentimes, developers forget to update dependencies that depend on the change variables, resulting in full system failures, which may be small or may even turn out to be catastrophic. One example can be the Nike Capital loss in August 1, 2012. So what they did was, while implementing a retail liquidated program, they implemented it to about seven of their eight servers. So what happened is that when they restarted the server, the zombie code, the undead code in the eighth server caused a loss of about $440 million in about 45 minutes. So the Knight's capital loss was not improper dependency check. It was not because of improper programming. It was due to improper dependency tracking. They did not implement a proper safety check, or they did not implement a proper dependencies, and they could not graph it out. As a result, they did not update all the dependencies, and at the end, they suffered this loss. There are other examples that can be, uh, for example, the NPM supply chain attack. So, how does Morris mitigate this issue? In Morris, you define the relation between multiple variables. What Morris does is that it tracks the variables and of declared variables, the values of declared variables, but other variables depend on it, and in what way each variable is related to each other. Once it detects changes to one of the variables, it automatically changes everything everything according to the said relations, thus removing entire classes of bugs such as outdated data or faulty failsafe. In addition to that, Voice also offers a system to test implementations before running it on the memory, the transaction engine. When turned on, the transaction engine acts as a sandbox that tests every input data and checks their effect on the memory. If it not only allows users to analyze certain conditions through the what if command, but also detects common coding errors like segmentation fault or null pointer, etc. So let me show you the reactive engine in action. Let's say I set x equals to, let me give you a basic example, set x equals to 12, set y equals to, let's say it depends on x in some way. You can see that x value is now 12, y value is now 72. So for some reason, let's say I change the value of x equals to 10. Now you would see it shows me a output updated y. If I check the end command, I can see that now y's value is 60. It was 72 before. So this is the essence of the reactive engine. The reactive logic, the first implementation of the propagation engine or the reactive logic was inspired by the Erlang Beam virtual machine. Erlang, what it did was a programming language that was used to handle telephone lines or telephone systems in the early 1980s through this same logic, the same reaction engine. But now the propagation engine is much more robust. But the basic implementation was this idea, actually. There are certain things to this. For example, let's say in imperative programming, you have if commands or if statements. So here we do not have exactly if statements. What we have is that reaction pattern matching, reaction pattern matching. So basically, the whole system is live. The whole system checks every variables, dependencies, and changes them accordingly. So it has pattern matching that is like a valve, that is like a path that checks for what condition, what value should the dependencies take. Let's say set A equals to, I would say 1, 2, 3. Let's say online equals to false. Okay. So let's say B is another variable that depends on A, let's say times 2 when online or else it will become, let's say, A plus 3. Now you can see that the B's value is 126. It shows it's conditional, means if online is true, then only A's value will be, B's value will become double of A, or else it will become plus 3. I showed you that A's value is 123, and since online is false, and now it's 126, if I set online equals to true, now I can see the value of Y is updated, and I'm sure that it will become 246 as defined in the expression. So what this does, what you should notice is that it does not only track the variables, it also tracks the expressions of how each variable is dependent on each other. One more thing you should notice is that everything is a generalized syntax. Let's say, let me clear this up. Let me type out the help command. You can see that everything follows the same pattern. It's verb and then it's target, verb, target, everything. So specifically, these are not commands. These are called intents. These are what you want the computer to do. I showed you an example for set. You can use the ensure condition where the ensure variable leverages the propagation engine to make sure a specific condition is true. You can use the write out command, something similar to print. Uh, Morse also takes .msh files. These are files, that Morse files, which are interpreted, uh, reads each command one by one because everything is follows the same grammar pattern. There are file navigation commands that are like page ls or cd that are normally in bash or PowerShell. What more thing that Morse provides for systems is that it's safety, its transaction engine that I mentioned earlier. So the transaction engine is basically something that checks a specific implementation, and only if it's safe, it writes them on the disk. Let me start a new session. Let's call this session test. Okay, session began. Its name is now test. It tells me that changes will be recorded until you forge. I use the forge command to write those changes on the disk, and I use the smelt command to basically discard the implementations that I just did. So let's say set t equals to maybe this. Let's say set rate equals to 10. Set time equals to 2. If I use the env command, I can see that these are unknown variables. These values are unknown. This basically tells us that these values are not written on the disk yet. You can use the inspect command to check all the implementations or what we have just declared. Let's say set in rest equals to p times rate times t divided by 100. It tells me that captured interest p. This is, if I check inspect, you can see that even interest is not calculated yet. It simply tracks the expression of how everything depends on it. Now, let me show you. We have something called a what if command through which you can basically check if something is, if let's say I use what if p equals to, maybe let's say 12, or let's say, okay, let me give you the full example. What if p equals to something large number, check memory. You can see that the condition check for memory has passed because it is an acceptable memory, in fact, only for two variables. Okay, let me check all of them again. Now that I'm sure that every implementation is safe for me, I can simply type forge it tells me the four changes, that is PT, rate, and interest. And if now I take the end command, I can see that they are now written on the disk. Yes. So the reaction engine and transaction engine, these two features make this language uh, proper, or make this language for areas where errors are not an option. You cannot afford an error. As per grammar and syntax, I showed you that it follows one generalized grammar. And I also said that for if statements, you have reaction valves that specify what values should take, what dependencies should take for certain conditions. Uh, so for now, you can see that all the commands here are generalized syntax idea. It's a bit alien as compared to normal scripting and programming. This is simply because Morris tries to prioritize flexibility and safety by design, actually. So what it aims to be is that it aims to be strong while alone and unbeatable with other languages like Python or C. So it does not actually replaces Bash, it makes other languages stronger by using it. So there are some specific philosophies or implementations that are, first of all, it was written in Rust because Rust provides high level readability and with low level control, inspired by functional programming languages like Haskell or Clojure. Now, one more thing I would like to mention is that the metaprogrammability idea. So, what Morris was initially designed to be was for systems where the system will stay live forever. And if you want to make some changes in the system, you cannot shut it down or recompile the whole program. In other languages, what you do is that you take the whole if you want to make some changes, you will write the code again, or maybe modify the code. You shut the whole system down, you recompile the whole program, and then restart the system again. But Morris aims to be sitting on a system where system is live forever. In older list machines or small talk machines, what it was that the operating system was on forever, was running forever. And if you wanted to make some changes to the operating system, you use the Lisp programming language to do it while the operating system is running. So what Lisp did was was able to achieve this by implementing something called a homoiconicity, where code is data and data is code. So whatever you put, you can also represent the same thing as data, and you can represent the same thing as code. That was the main reason why everything in Morris is said to be a string. When you set everything, it's something called it's totally a string. And when the variables are uh, listed in a dictionary that is written in Rust, even the dictionary is also treated as a string so that Morris can check its own source code, can check its own list, its own memory, so that it can make changes. So what this lets you do, this meta programmability ability, it lets you bend Morris to your will. Let's say you have something, but the Morris is not designed to do. You simply use the define, I believe, the define intent or the execute intent command, both of them, to make your own intents, to make your own commands, and then you can use it. So basically, it allows you to bend it to your will, to your own convenience. Uh, so what you can do is that Morris was designed for system admins, server managers, or security professionals because of its propagation in military applications, because of its self programmability, so that you can make changes immediately. This can be used by programmers, AI developers, or engineers that will be used as combined with other languages, provides quick debugging and fail-safe techniques. So all the implementations were not new and actually uh, inspired by other proven concepts. I did mention earlier that the reactive engine is inspired by the Erlang Beam virtual machine for handling all the telephones handling the telephone lines. It is not object oriented, it is functional, like for OCaml or Haskell. So, in fact, a lot of things like the async await, these are future features. Uh, there are other future features such as foreign function interface, where it can talk to C programming language. You can use the external commands so that you can handle networking databases and other softwares. Bootstrapping is currently being done because there are Rust libraries that are used to make this language, and you can specifically use .msh files that are Morris files, so that you can replace all these the dependencies one by one with Morris scripts. And later you can use it for AI orchestration because AI understands declarative expressions over imperative statements. So originally, Morris was designed for an AI-powered operating system where it will sit as PID1, process ID1. It will handle all the total entirety of system, and if you want to make some changes to the system, you have to write it on Morris. In future, it actually best fits for another language that I made. Is called Relic, that will be a replacement for C in making that operating system. And so basically, Morris and Relic are two languages that will be easier, that will designed so that they can be interchanged with each other, and they can also talk to each other in their own languages so that they can make the changes, necessary changes to the operating system. So that's it. I would like to thank you all. Have a nice day.